We're going to do another problem where we are going to find the moment, the resultant moment about a point. So determine the directional sense. That means, are we going counterclockwise or are we going clockwise? So positive, negative, and the magnitude of the resultant moment about point A. We have 1, 2, 3 force vectors that are creating a moment about point A. And again, we're going to use right hand rule, which means if I stick my hand right here at A with my thumb coming out of the page, right hand rule positive is counterclockwise. We're wrapping that way. So the first thing I'm going to do is I should draw a free body diagram, but we're going to just draw it here. And I'm going to recognize, here's point A, that these vectors actually have components. And this one right here, F1, is 150 newtons. So I have 150 newtons. And so this time it's going to be a cosine 30. And I have 150 newtons, sine 30, okay? And we come over here. F2 is 200 newtons, so I have 200 newtons, cosine 60, 200 newtons, sine 60. And we're going to use a different color down here. And this one is broken up with our rise and run. So I'm going to have in the x 3 divided by 5, so 3/5 times 75 newtons. And here I have 4/5 times 75 newtons, okay? So if we're writing the equation using the scalar format, here's A. We are going to sum, this is my rule, I'm summing what? I'm not summing forces, I am summing moments. And I'm summing them specifically about point A, and I'm using right hand rule positive. Okay, so that's my rule. I'm going to start here at A this time, and I'm going to work my way around my system. So as I come across, I'm going to look right here at my x component of 150 sine 30. I'm going to make my watch hand like so. I'm connecting it at A, and I'm going to pull, okay, with my x. So it's just providing translation. The distance is 0. It's coming straight through there. Fx dy. That distance, 0. I also know I'm going to have an Fy dx. So now we're going to look at this y vector coming up and down, perpendicular distance, okay, Fy dx. Clock handle. Here is my clock handle coming along this perpendicular distance. I am pushing down on my clock handle. And I can see it does cause rotation, and specifically it's causing clockwise, so we know that's negative. So I have a negative 150 newtons cosine 30, and its perpendicular distance is 2 meters. Now it's not negative because this is a negative y component, okay? It's negative because it's causing a clockwise or a negative rotation back around A. So let's come over here. Let's move to our F2, which is our 200 newtons. I am going to look here, and I can see that that x component goes straight through A. There's no rotation happening. I would be just trying to pull that clock handle, pushing or pulling it off. Okay, so it's an Fx dy. There is no distance. The distance is 0. It's running right through that point. Okay, now I have an Fy, so I'll need a dx. If I look along my vector line, perpendicular, okay, so that's going to be this entire length all the way back. Okay, it is heading down. If I put my clock handle on here at A and I hold it and I push down in a direction, I can see that it does indeed spin like a clock handle. So that is going to be clockwise, which is negative. You can also see rotation is backwards. Okay, so we indeed have a negative 200 newtons sine 60, and its distance is 2 meters plus 3 meters. we're having to walk 2 meters and then an additional 3. Now let's come down here. So we're going to start with the x. Okay, and the x vector actually runs all the way from infinity to infinity, and I need the perpendicular distance to A. So that's going to be straight down my y-axis. There's my perpendicular distance. I can look over here. I can see that's 4 meters. And I'm going to make my clock handle, attach it, put it on the y-axis, and I'm looking at the direction of that x force. It's pushing to the right. I can see that rotation occurs. It's counterclockwise. So I have a positive 3/5 times 75 newtons, and its distance is 4 meters. Okay, now I'm going to look at the y. Here's my y running along. Perpendicular distance back follows the x-axis. Okay, so that dx is the same as it was for my blue vector. I'm going to attach my clock handle along the x-axis. I'm going to push my force down just like I'm seeing the direction traveling, and I can see rotation, negative, minus 4/5 times 75 newtons. And my distance, okay, my distance is 5 meters. If I have a force in the y, I have a distance in the x. Okay, if I have a force in the x, I have a distance in the y. And now, when I add all of this up, I get that the moment about A equals negative 1245.83 Newton meters. I can check everything has a Newton meter, Newton meter, Newton meter, Newton meter. Okay, I've got force distances. But I'm going to just go ahead and show you 1245.83 Newton meters. It's negative, so it's actually twisting in this direction. Okay, so instead of calling it negative, I'm going to show direction. I'm assuming we're all using right-hand rule. But if you're using something different, you may have not a negative there. So we're just going to show. When I have a moment, I'm going to have a magnitude, and I'm going to have a unit, and then I'm going to show direction.